So let's maybe start with bias and fairness. Bias can kind of creep into AI in several ways. I mean, human decision-making has long suffered from implicit biases, right? Think about lending racial or gender disparities in credit approvals. They've existed for decades. AI models, well, unless AI fairness becomes like a core design principle from the start, they risk just perpetuating these same biases.
Right, baking them in.
Exactly. We see this with Stable Diffusion, for instance. It mirrors biases and misconceptions that were present in its training data, the LAON5B dataset, and that leads to images that can reinforce social biases. They tend to be, from a very Western perspective, largely because it was primarily trained on images with English descriptions.
That's a really crucial observation. It highlights how deeply ingrained this stuff can be. So in practical terms, how does this bias translate into real-world impact? And more importantly, what tools are being developed to actively try and combat it?
Well, a clear case study is loan adjudication, like we mentioned with lending. Imagine a probability of default model, right?
Right.
It might reject male applicants more often, even if they are creditworthy. That's a higher false positive rate. Or conversely, it might approve female applicants at higher rates, but then they might struggle more with repayments. That's a higher false negative rate.
So unfair outcomes either way.
Right. In one baseline model they looked at, there was actually an 8% gap between groups in what's called equalized odds difference. That's a metric that checks if the error rates are fair across different groups. Now, to combat this, there's the open source Fairlearn toolkit. It's a Python toolkit from Microsoft, actually. It's designed specifically to assess and mitigate these fairness-related harms. It focuses on group fairness, using metrics like demographic parity, which aims for similar outcomes across groups, and equalized odds, which focuses on ensuring fair error rates, like we just talked about.
Yeah.
And by applying Fairlearn's mitigation tools, things like threshold optimizer and grid search, a team was actually able to cut that equalized odds difference down to just 1%.
1%? That's a huge improvement.
Massive improvement, yeah. And while maintaining the overall accuracy of the model. And there are other valuable tools out there too, like IBM's AI Fairness 360 and Aequitas.
So it really sounds like ensuring AI fairness requires looking beyond just the algorithms themselves. It's the whole life cycle, the broader societal context too.
Precisely. It really is what they call a sociotechnical challenge. It demands transparency. It needs ethical oversight, which means working with legal experts for compliance, for example. And it requires continuous monitoring of these models because societal norms change, data drifts. The good news, though, is that these tools show that AI fairness doesn't have to come at the expense of performance.